This video is going to be several examples of counting questions. So we're going to go through and use what we know about counting techniques to try and answer each of these. So the first question says you're taking a quiz that has 11 multiple choice questions. If each question has 4 possible answers, how many different ways are there to answer the test? So the first thing that I always recommend here is that you ask yourself whether or not repetition is allowed. So I'm going to just put up here, number 1, is repetition allowed? And if the answer is yes, then we're going to use our just regular multiplication rule. But if the answer is no, then we're going to move on and try and decide between permutations or combinations. Okay, so this says you're taking a quiz that has 11 multiple choice questions. Each question has 4 possible answers. And so I've got 11 spots to fill, basically. And so what I want to know is repetition allowed? So I have 4 choices for each one, right? So like A, B, C, and D. If I use A here, does that mean I cannot use it again here? And the answer is clearly no, right? I could repeat as much as I wanted to. So is repetition allowed? The answer is yes, which means I'm just going to set this up using that basic multiplication rule. I've got 4 choices for the first one, right? A, B, C, or D. I've got 4 choices for my next answer. I've got 4 choices for my next answer, and so on 11 times. So this is 4 to the 11th power, which is 4,194,304. Okay. Next one, moving on, says how many 3-letter words can be made from 4 letters, F, G, H, and I, if part A, repetition of letters, is allowed. So again, if repetition is allowed, and I have 4 spots to fill, I have 3 spots to fill, right? How many 3-letter words can be made from 4 letters? So I have 3 spots to fill. Repetition's allowed, so I have 4 to choose from here, so F, G, H, or I. I have 4 to choose from here, and I have 4 to choose from here, so that's 4 to the 3rd, which is 64. And if repetition is not allowed, that's where we start thinking either permutations or combinations. And so the question I would ask was, does the order matter? And if we're making words, then certainly the order of the letters matters, right? CAT is different than TAC. And so order matters. That is a permutations question. So I could look at it in 2 different ways. I could either just know that I have 3 choices and I have 4 for the first, 3 for the second, and 2 for the last. Or I could call this 4 permute 3, right? So either of those would work. Those are doing the same thing. So 4 permute 3 gives me 24. And you can tell 4 times 3 times 2 is also 24. So you could do either one. Next one there says, a pianist plans to play 4 pieces at a recital. In how many ways can she arrange these pieces in the program? So this would be a case where repetition is not allowed because she's not going to play the same song 4 times. But the order matters, right? Because the program is going to change depending on which order she plays the songs. And so this is actually 4 permute 4 because she wants to play all of them. So she has 4 songs to choose from, but she wants to place all 4 of them, and that is 24. Next one says, in how many ways can first, second, and third prizes be awarded in a contest with 210 contestants? So again, is repetition allowed? Would I give the same prize first, second, and third to the same person over and over? No. So repetition is not allowed. And then I need to determine if order matters or not. So combinations or permutations. Because this is a first, second, and third prize, I think that implies an order, right? So first prize is different than second or third. And so this is a permutations question again. We have 210 individuals, and we want 3 of them. So 210, permute 3 is 9,129,120. All right, continuing on here, the next example says 7 Olympic sprinters are eligible to compete in the 4x100 meter relay race for the U.S. Olympic team. How many 4-person relay teams can be selected from among the 7 athletes? So again, is repetition allowed? No, we can't have the same athlete run all 4 legs of the relay. And then does order matter? So the order that we're placing the athletes in to run does change what the race looks like. And so order does matter. And so out of 7 eligible sprinters, we're going to permute them, and we want 4 picked for the relay. So it's a 4-person relay. And so again, back to the calculator, that's 7 math probability NPR 4, and we get 840. Okay, so there's lots of examples for you of permutation questions. Next page says, in how many ways can 4 different pizza toppings be chosen from 12 available toppings? Okay. In this one, we aren't given information about whether repetition is allowed or not. So usually if we're not given that information, then we usually are going to go ahead and assume that it's without repetition. So I would not be picking the same topping multiple times. Does the order that the toppings are placed on the pizza matter? I guess depending on how much of a pizza connoisseur you are, you might change your answer there. But I would argue, I guess, that the order of the toppings doesn't matter. All that matters is that they're on there. And so this would be a combinations question, which is 12 combination 4. Which is 495. Next one here says, at a baby shower, 17 guests are in attendance and 5 of them are randomly selected to receive a door prize. If all 5 prizes are identical, in how many ways can the prizes be awarded? Assume no one can receive more than 1 prize. So they're telling us there that repetition is not allowed. That means we're going to combinations or permutations. And it says all 5 prizes are identical. So you're going to get the same thing whether you get the prize first or second or third or fourth or fifth, which means the order does not matter. So out of 17 guests, I want to choose 5 of them to get the prizes. And so that can happen in 6,188 different ways. Our next one here says, in the 650 lottery game, a player picks 6 numbers from 1 to 50. How many different choices does the player have if order doesn't matter? So this is, again, a lottery question, and any of our lottery questions are generally going to be combinations because the order doesn't matter. So there are 50 numbers to choose from, and we need to select 6. So 50 combination 6 gives us 15,890,700. Number 9 says, how many ways can 5 different cards be dealt from a standard 52 card deck? Again, our first question is, does repetition, or is repetition allowed? And so once I deal a card, I can't deal that same card again, right? So repetition is not allowed. So that means we're looking at combinations or permutations. And for just a standard 5 card deal, it doesn't matter what order you get the cards, it just matters what 5 cards you get. And if order does not matter, we have combinations. So this is 52 combination 5. Which is 2,598,960. And then the last one here says a jury pool consists of 18 people. How many different ways can 3 people be chosen to serve on a jury? So they need to select 3. The pool is 18. Is repetition allowed? No, because we can't have the same person. We need 3 unique people. And then does the order that they're chosen matter? The answer is no. The order can be different. It still represents the same 3 people that are chosen. And so this is a combination question, 18 combination 3. And you get 816 there. So what you'll notice as we worked our way through these problems is that the mathematics is not the hard part. We're doing that on the calculator. The challenge is deciding which counting technique to use. And so again, I highly recommend that you walk yourself through these questions every time. First, is repetition allowed? If yes, we're just using that basic multiplication rule, but if no, then we have to decide if we're using permutations or combinations. And again, permutations is if order matters, and combinations is if order doesn't matter. Okay.